Hello everyone. In this video, let us solve one problem on parabola by focus directrix method. I will not write complete statement of the problem. I will write only important things which are given. It is given that distance of focus from directrix 50 mm. Distance of focus from directrix is 50 millimeters. And we are also asked to draw tangent and normal to the curve at 25 millimeters from focus. Draw tangent and normal. At what distance? 25 at 25 millimeters from focus. Now let's draw parabola first. For that we need to draw vertical line which is directrix. Then somewhere in the middle draw horizontal line which is axis of parabola. What is this? Fixed vertical line, directrix, and this is axis. Now on this axis of parabola, let us locate fixed point, that is focus. Focus is at 50 millimeters. Okay. I am taking some proportionate sketch as per the big size of this board. See, my focus is here. At what distance? 50 millimeters from directrix. Now let's locate vertex for this parabola. Vertex will be at the center point, that is midpoint of this line segment. Let us call this point as a C. It will be at the midpoint of the CF segment. Where is that vertex? It will be at 25 mm distance. Here. This is the vertex. What is vertex? Vertex is a point common to parabola and axis. Means it is the point of intersection between axis and parabola. Now after this, divide this line ahead of vertex into number of parts, not necessarily equidistance. Take 6 to 7 points, which is enough for the construction of parabola. Draw parallel lines through this. Let us name these points 1, 2, 3, 4, 5, 6. Draw vertical lines through all these points. We can include focus or you can exclude focus also as per your wish. Better to use drafter for drawing these vertical lines while solving problem on drawing sheet or in sketchbook. Okay, let me extend these lines. Okay, after this, just wait. Take distance equal to C1 in compass. Take distance equal to C1 in compass and taking F as a center, focus as a center, cut first vertical line on both the sides. See, call this point as P1 and this point as P1 dash. What we have done? What distance we have taken? C1 distance. And by taking F as a center, we cut this first vertical line on either side. This distance is P1F, which is equal to C1, and distance of this point from directrix is also C1. These two distances are equal, means this is C1, this is C1, and how much is this? This is also C1. That's why, see, if we join this point to focus, this distance is C1, this distance is also C1. Therefore, P1F upon P1, let's say this point is M is equal to how much? 1, because these two distances are equal. That's why this point should lie on parabola. Similarly, this point also is lying on parabola, because this is again C1, this is C1. Therefore, these 2 points are lying on parabola. Repeat this procedure for remaining points also. Okay. Now next, take C2 distance in compass. Keep your compass on focus. Cut second line on both sides. This point is P2. This point is P2 dash. Repeat this procedure for remaining points also. Then take C3 distance. Keep your compass at focus. Cut third line. This is P3 point. This is P3 dash. Next is C4. Center is focus. Cut fourth line on both sides. P4, P4 dash. Then C5 distance. C5 distance. Taking center as focus. Cut fifth line. This is a P5 point. This is P5 dash. And for me, this is last point. Take C6 distance in compass and cut the line passing through 6. This is P6 dash and this point is P6. Now draw a smooth curve passing through all these points. We get parabola by focus directrix method. For that, let us use some different color chalk. Okay. Now let us finish it. While solving this problem on drawing sheet, you can use French curve also. Now the next part of the problem is left. What is that? Draw tangent and normal to the curve at what distance? 25 millimeters. 25 millimeters. Let us take 25. Here we have that distance. because this distance of focus from directrix is 50, therefore midpoint of that, which is vertex, it is 25. Okay, keep your compass at center, means taking, see, means we have to draw tangent and normal at this point. Okay, for that, draw a line passing through focus and this point, focus and this point. After that, draw line perpendicular to this line. Okay, perpendicular to this line. Extend this line such that it will cut this directrix at some point. Okay, what we have done, we have located this point which is 25 millimeters away from focus. From this point we have joined, we have drawn line by joining point and focus, this line. We have drawn another line which is perpendicular to this line, which is cutting directrix here. Okay, now after this join this point with this point and further extend that line, which will give you tangent, What is this line? This line, yellow line, is tangent, and line perpendicular to this line at P will give normal, This is normal and this is tangent. In this way we have drawn parabola by focus directrix method, and we have also drawn tangent and normal to the curve at given point. Okay, for drawing this 90-degree line we can use a drafter or set square. Okay, I have not used that set square or drafter here. I have tried to draw the curve to the best accuracy as far as possible on this board. I hope you must have understood this problem very well. Thanks for watching. We will meet again in the next video with another problem or concept. Till then, goodbye.